Okay, this is Senior Design Lab 2, and this is Teeter. Say hi, Teeter. He doesn't talk much. Anyway, we have a transmitter. It's an IR transmitter emitter, and we've got an IR receiver. And basically, so it's sending a 430 hertz signal, and it's roughly a square wave because it's being generated from a square wave from a 555 timer. When we interrupt the beam, the signal goes to basically 0, and when we remove it, it frees it up. Teeter likes very clean, high-order filters, and we did a pretty good job. There's some kind of ring there, but that's fine. We can only expect so much because technically to go from there to there would be like an infinitely fast, and there's only so much bandwidth on these op amps that we're using. We're using 4 chips in total, but 5 op amps on the chips, 2 buffers, and then for making sure that we don't load various stages. Oh, and I just sat between it. Also, we can see if we move the signal away, it decreases, but it's actually pretty tolerant to that, so there we go. We've got a software filter running a 6-order Chebyshev type 1, so it also targets. So we're basically doing the same thing with a multi-feedback bandpass filter in hardware and also in software. We can get tighter filtering on software, but just to clean up the garbage so that it doesn't even have to, it's not going to artifact in whatever we have later, I opted for a hardware stage, just given how easy it is to simply add in a single chip to do this filtering. We had to preamplify it first, so the first stage is a preamplifier, then followed by a multi-feedback bandpass filter in non-inverting configuration, and then a non-inverting amplifier to bring it up to the final gain, and then we voltage divide it down for the ESP32's pin. The signal tops out, I think, if let's see what it tops out. Teeter, there we go. Yeah, so it's clipping about there. Yeah, so it should top out at 3.2 volts. So that's gives us a little safety room below the 3.3 volts that the pin can take. We don't get to use the full range of the ADC because of that, but it still works, and the clipping doesn't affect the thing. So yeah, this is pretty solid. There is a little bit of a tiny DC offset that I was noticing. There's some ground looping we've got, but when we put this over to a PCB, it should improve performance significantly. The rough performance from the op amps will be the same, so I'm not sure if that could really be improved at this point, but yeah, that's what we've got.